Do you want to learn the beauty of advanced calculus? That might be the question that you're asking yourself day and night, and possibly that you have ever found the right answer for that best engineering questions. And I think that you have to answer yourself when you join to these programs. You'll get the answer yourself, and then the answer might say that yes or no. And then I'm ready to join with our online institution. My name is Olenjolai Moko TAYAI Losingo. Simply call me Olenjolai. I'm a Tanzanian. I'm doing these programs specifically for undergraduate students in Tanzania. I love so much my country, and this is the gift that God has given me for my nation. And the reason for me to make this content free of charge, it's an assignment I've been given by God as one of the calling and an assignment that I have to accomplish myself before I die. So this is a gift that for Tanzania. I would like to just take this opportunity to just give God thanks, first of all, who have created me in his own image and likeness, and I really honor him, and I thank him because he's the one who called me and the one who gave me the visions of being a practical, or just we call it just it means that a practical or an exceptional or a unique teacher of engineering and the mathematics, right? So I thank God by his own grace that I'm going to teach you the beauty of higher engineering and scientific mathematics in this online institution. And I thank God also that I'll be teaching you with the wide focus, with the broad focus, with the for example, that the first focus, the national focus. I will teach you the higher engineering and scientific mathematics that undergraduate engineering students or bachelor engineering students and certificate students in Tanzania, they really need to know it, and in order for them to succeed in exams, and also succeed in applications of this concept in different fields of engineering and science, and also succeed in solving real life problems according to the field of study that you are doing right now. So I ask you just to join me, and then just pay your attention and be ready to be transformed and be ready to receive the good news, because we thank God by his own grace that we have a good news. So the second focus of this online institution is we are focusing the entire continents of Africa, Asia, Europe, America, and Australia, because higher engineering and scientific mathematics is universal. I want to tell you that we have students. For example, we have one of our students who is studying, who has nationality of Serbian, who is a Serbian. So we have so many students, so many different students across the world or around the world. So we are here in order to make sure that we transform them radically from the present state to the next state. So I'd like to take this opportunity first to welcome you into one of our online schools. Our online institutions is called Online Undergraduate Polytechnic Institute of Tanzania (OLENJOLAIM). And we'd like to welcome you into one of our YouTube channels, that official YouTube channels that called Online Undergraduate Polytechnic Institute of Tanzania (OLENJOLAIM). And we are in departments of higher engineering and scientific mathematics, and we have a module or course that called Advanced Calculus. Wow. So what are we doing in Tanzania, in Online Undergraduate Polytechnic Institute of Tanzania (OLENJOLAIM)? We have an assignment to teach and train undergraduate students on how they can extract knowledge, wisdom, and understanding from the fundamental course in engineering and scientific mathematics, and also from their core courses, and combine it with the knowledge, understanding, and wisdom that we are teaching them to extract it from the Word of God written in the Holy Bible in order to solve real life problems. The main objective of educations is not to have certificate. The main objective of certifications is not to sit for exam. The main objective of educations is not to start to be famous. The main objective of any education in any country, in any city, in any community is to solve real life problems. So I'm very passionate to see my continuing students and even graduate students. They are telling me, "Sir, thank you, Sir Olenjolai. Now I'm solving real life problems. Thank you, Sir Olenjolai. Now you gave me just some concept that I'm applying on solving my own problems." That is our that is our rejoice. That is what we be boasting ourselves before God. That God, we thank you because we have impacted the life of students and the life of your people who lives in Tanzania, and even those others who are not living in Tanzania. So that is our focus. So we'll be teaching you about what we need. We know that what you are focusing right now about the educational systems in Tanzania. You are focused on exams, just a continuous assessment on the TAFE, and that's all. We know that's what you are seeking for. And we are giving you that in order to reduce your stress. I know that. These visions what I want to achieve with all my students, but some of them will achieve them, especially those who want to do or want to learn and go extra mile. Extra mile means that you should not end when you learn particular concept. Don't accept that concept to have the end life during the end of semester exam. That is a wrong idea. So stay with me. Myself, I'm a product of what I'm telling you. What I'm teaching you is what I'm living in for the rest of my life. So I'm solving real life problems. For example, the one that I'm solving in the national level. I experienced this problem myself. My classmates have experienced it. Even the current students that will experience these problems, because mathematics is a kind of the tricky subjects, and actually it's a very interesting if you understand and master, and it's a very good subject if you learn it systematically, right? Again, I would like to spend a few minutes to orient you on how you can register onto OPITO. OPITO, it's abbreviations of Online Undergraduate Polytechnic Institute of Tanzania, square bracket, OLENJOLAI. So the first step, we ask you that to create or open a new email, right? In case you don't have one, if you have any email, you can decide. You can have two emails and then you sign in both. For example, myself, I have Yahoo email and Gmail, and I sign in into different channels, YouTube channels. I sign in by using the different emails. So for example, if I sign in YouTube, there's a notifications, I will get it just by using the Yahoo. And if I sign in, maybe I sign in, the next day I sign in by using my Gmail account, then I get notifications that will be provided by YouTube community and will be sent to me through the email address. The aim for you to sign in YouTube is in order, and the aim for you to fail to subscribe in order for the YouTube to get an address so that they can send to you the notifications that right now Olenjolai has added a new video, right? So that is the objective. So the second step, we ask you to sign in by using your email. And what you can only just sign in if your email and password is valid. The third step, we ask you to search OPITO. Don't write OPITO. Just search just go to the YouTube search engine and then write Online Undergrad POLYINSTIT of Tanzania square bracket OLENJOLAIM. So you'll see the round buttons are these ones, and then you'll see the number of videos. You'll see the names beside it, Online Undergraduate POLYINSTIT of Tanzania in square bracket OLENJOLAIM. You see the number of subscribers. So you see those three information. Just click here, click on this button, and then the YouTube will send you into our OPITO schools or our OPITO institution. Then we see the horizontal toolbar, which is written songs, videos, playlisting. Then we have what? So playlisting, this playlisting community, channel community about. So then we ask you that just go below of the video, just check the right, the bottom of the right of your right hand side. You will see buttons written subscribe, red in color. It has the backgrounds of the red backgrounds and the white in color. Then we ask you to click it and then go to. So and then you do. So click it. And once you click it, it will change the text into subscribing, and soon you'll see icons of bell. We ask you to click this icon of bell. You'll see three options. Choose the options of all. Once you finish that, you have registered yourself permanently in OPITO. You don't need to register once again next time. So when you come the next time, no need for you to register. You just get in class. Wonderful. And our registrations is free. And why should you register? In order for you to get notifications, because we have a vision to record more than 600 videos of teaching and training the beauty of higher engineering and scientific mathematics. Mathematics is beautiful, and I want to tell you mathematics, it's the queen of engineering. So if engineering is the king, then mathematics is the queen, right? Practical, especially practical engineering, not theoretical engineering like the one that we do in our country. So you have registered yourself. Let me just take you, just orient you and just give you orientations on how you can access our content easily. The first step, you can click this horizontal bar, the third toolbar, which returns playlisting, and then set the playlist returns gamma and beta function. That in that playlist, you will find the collections of videos about the beta and gamma function only, from the first lecture to the last lecture, right? We have also a playlist of advanced calculus. So that playlist of advanced calculus contains the video from the videos from the first video of the first chapter to the last video of the last chapter. So that's how we organize. We have also, because we have departments, we have also a playlist that's called the Higher Engineering Scientific Mathematics. So that contains all the sessions, all the lectures that we've taught in under departments of Higher Engineering and Scientific Mathematics, because that's the department. Okay? So take advantage of that. Then you can also take advantage of our other official YouTube channel. We have a total of 6 official YouTube channel, and we are creating contents every day. So we thank God by His own grace, He called us again in this year and at this time to create contents, distribute, impact, have dominions over the different places, over the teaching industry, and then impact the life of people, and then wait the fruits of solving real life problems. So you can click the channels, and then you'll see our other 5 channels. So you can join or you can subscribe. Also, you can register yourself by subscribing, and then you get notifications. For example, we have another official YouTube channel called Kingdom of Heaven Comes in Tanzania, in square bracket OLENJOLAIM. In that we are learning the Word of God in English, and we are learning by using just our mother tongue. So just that, because our first language is Swahili. So we are learning the beauty of Jesus and the beauty of the kingdoms of heavens. We are praising God. We are worshiping God. And that is personal worship, personal praise, and personal knowledge about God. And we'll be extracting knowledge, understanding, and wisdom from that department, or from that online school. That's the example. The 7th step, I know that we enjoy our contents. You can share our contents with by clicking the icons at the bottoms, at the right hand side of the bottoms of the video. You can click the icons of share in order to share the video links to your friends via the social media. For example, via Facebook, via WhatsApp, via email, via Telegrams, Instagrams, SIR, Twitter, etc., etc. So, ladies and gentlemen, I would like to welcome you in departments of Higher Engineering and Scientific Mathematics. The models of the course of the day is called Advanced Calculus, and then this is what this is class. These contents are for the first year BNG or Bachelor in Science in NTA Level 7. This is Chapter 1, Gamma and Beta Function. So simply you have to know that this module is for the first year undergraduate students, but in some of the universities they learn at the second year. Don't worry about whether the first semester, second semester, third semester, or fourth semester. I told you that you should have the course outlines, which it will mention, because in every session or in every lecture, in every topic, or in every modules or in every course, I mention the contents that you are going to cover. So you can check what you are required to cover, and then you come and extract it in OPITO in order to go extra miles as an excellent students in Higher Engineering and Scientific Mathematics. So, ladies and gentlemen, let us go into today's business. Let me start. Let me join lecture 2. Excuse me. This is lecture 3. Let me join possibly lecture 1, lecture 2, lecture 3. So that's what we call a quick review of lecture 0, lecture 1, okay, lecture 2, lecture 1 and 2, right? So the quick review, because these are close connected or related, these are closely related lectures. So the quick review, basically, we say that we have a function we call it gamma. So gamma is a special, we call it a special improper integral function. It's integral from 0 to infinity. Then we say that we have e power negative x, then we have x power n minus 1, then dx is the integral formula. Okay, remember that formula. Then again we say that we have 3 gamma properties. The first one, we say that gamma of n plus 1, this is equal to n gamma of n, like this one. This we call it recurrence. Very important. So this we call it recurrence formula. So recurrence formula, and we use it effectively. Remember also we can divide by n to both sides, and then we make gamma of n the subject, and you have used it in different aspects of this topic. So here you have gamma of n plus 1 over n, right? The second property, which will be using, or we have used it and will be keep on using, is gamma of n plus 1. This is equal to n factorial. Remember, this was example 1, and this was example 2. These had 4 marks in exam, these had 6 marks to prove. whether it is true. The third property of gamma, we say that gamma of n times gamma of 1 minus n, this is equal to what? This is equal to pi over sine of 40 of n pi, and we left it as an assignment for you to prove. So in lecture 2, basically we began to apply these gamma properties, okay? Gamma properties on solving the problems. So we discussed it. So I told you how you can find gamma of what? So gamma of what? Of positive integers, right? And then I taught you how you can find gamma function of what? Of negative integers. So in case you missed it, you missed lecture 2 and lecture 1, you can access in our YouTube channel. So let us go into today's business. So today we are teaching about the beauty of gamma function of positive and negative fractions. So we are still applying what? Gamma properties on solving or on finding the values of gamma functions of what? Of fractions. In lecture 2, we learned on whole numbers, on integers, right? We learned on integers. So today we learn some gamma functions of fractions. It's very important, and this is the foundation concept that even later on we'll be solving, when we'll be applying the integrals, so applications of gamma in solving integrals, the finite integrals, or infinite integrals, then we'll find that these properties or these techniques will be using them in maybe at the end of the solution. We'll be given the integral, we'll be simplifying, integrating, but later on we'll find that we end with gamma of maybe 5/2. That's a gamma of positive fractions. So then how can you simplify that? So we'll be repeating this concept, and you should not claim you'll understand for the rest of your life. So today let us focus on what? So let me start with the first part. Okay, gamma function. Stay with me. Gamma function. Say it again. Gamma function of what? Of positive. Gamma function of positive. Gamma function of positive what? Fraction. Gamma function of positive fractions. Okay, gamma function of positive fractions. Okay, so gamma function of positive fraction. Gamma function of positive fraction. Tell your neighbor, are you ready to enjoy the beauty of gamma function? Ask your neighbor, please. And ask your neighbor again, do you love gamma? Do you love advanced calculus? If the answer is yes, then tell him, okay, so let us now kick them the concepts and learn it. Okay? Okay. So I say that in improper integral, to find the value of gamma function of what? Of positive fraction. Positive fractions. We employ what? We employ two gamma properties. Okay, gamma properties. So we're going to use two gamma properties. And these two gamma properties I taught you, the first one is the recurrence formula, which is gamma of n. Okay, these are gamma of n plus 1. This is equal to n gamma of n. And we can simplify it that divide by n. So let us reverse. So you have gamma of n. This is equal to what? Gamma of n plus 1 of what? Over n. Okay? Over n. So that's the concept that we have to make sure we have to cover it. Okay? So this is the concept that, so this is one of the formula that we are going to use on solving these problems. And it's very interesting. Okay? So the second property, so this is the first property, right? The second property, it's a one that I left you to prove, but in case you fail to prove, don't worry. Gamma of n, this is gamma of 1 minus n, this is equal to what? Is equal to pi. Then we have what? Sine of n pi. Okay? So this is another property that we are going to use it to get common value. And this common value, so please, you can pause the video and then copy those steps. Just 4 steps for registrations and 3 steps for you to access our content without too much hassle. Have you finished? Okay, so let us continue. So ladies and gentlemen, we can find the gamma function or the gamma value of 40 of a positive fractions by only using these 2 properties. Are you ready to receive the good news? Are you ready to learn something new? Let us go into the business. So let us begin with the previous session. Okay. So let us begin with the question we have here. So it was example 2, 3, 4, 2, 3, 4, and 5. Okay. So that will be example 6. Wonderful. Okay. So you have this is example 6, ladies and gentlemen. If I'm not mistaken, numbering. Okay, example 6. And this question has been asked in our end of semester exam. So refer DIT, Dar es Salaam Institute of Education, DIT final exam or end of semester exam of 2015, of academic year 2015-2016. And this question was one of the questions in section B. Okay, section B. Okay, it was question 2. Okay, it's not a difficult question if you know, but if you met with it for the first time, then you see that it's one of the toughest questions. Use gamma function. Use gamma function. Why are you limited to use gamma function? Because there's an alternative technique of finding out, of solving this problem. Use gamma function to show that use gamma function to show that gamma of half is equal to under root of half. Okay? And then if you do that question, you will be awarded 5 marks. If you did it successful, then be awarded with 5 marks. Have just to show that gamma of half is equal to under root 5. And why are we teaching you this concept before even teaching about gamma of the fraction? Because a half is a common fraction that you're going to find in most cases. So we'll be having gamma of half. So we'll be asking ourselves what the gamma of half. So you have to record this. That's why I have to teach you this example before I teach you. So you can pause the video and then try to solve it yourself. Pause the video and then try to prove it. You can try. Okay, thank you for trying. So let us go into the business solution. So solution, we say the first step, for you to prove this formula, you need to say that we call the gamma property, the same gamma property, and this is gamma of n times what? Gamma of n times gamma of 1 minus n. This is equal to pi over sine of n pi. Right? So you have the left hand side and right hand side. So that is the formula, or this is the property. So we say that gamma of n times gamma of 1 minus n is equal to pi over sine of 40 of n pi. So we say that, let us continue. Let n is equal to a half. So either the case, so we have what? Gamma of a half, then times what? Gamma of 1 minus a half, right? This is equal to what? Is equal to pi sine of what? Sine. I think that let me do it this way, okay? Let me minor changes. Let me organize this solution for slow learners, intermediate learners, and the faster learners to understand. The first step, we call what? We call the gamma called the gamma property. The gamma property is gamma of n times gamma of 1 minus n. This is equal to pi. Then divided by what? Sine of what? Of n pi. So suppose that this is equation 1. Then we go for the second step. Second step, we say that let what? N is equal to 1. So then what? Then substitute n in what? In equation 1 above. So to substitute n in equation 1 above, then what do we find? So now it's a time to enjoy the beauty of gamma function. Alright? What am I teaching you? I'm teaching about the gamma function of positive and the negative fractions. That's the main objective, but these are the ways to get there. So if you substitute n is equal to a half, you have gamma of a half times gamma of what? 1 minus a half. This is equal to what? Is equal to pi over, then you have what? Sine of what? Of n, which is a half pi. Right? So if that's the case, ladies and gentlemen, if you do just use the simplification, 1 minus a half is equal to what? Is equal to a half. This is equal to pi of what? Over sine of pi over 2. Right? So this is the same function. So if it's the same function, say that gamma of a half, then now we can use the square brackets to so it is squared. So this is squared because same something. So because here we have a multiplications operation. This is equal to pi of what? Over sine of pi over 2. Then we go for the third step. Third step, we say that from the concept of what? Or special angle, where pi, remember pi always, pi radian is equal to 180 degrees. So it means that pi over 2 radian at angle, this is equal to 90 degrees. So it means that we are looking at sine of what? Of pi over 2, which is equal to sine of what? This in terms of radians, sine of 90 in terms of degree, which the answer is equal to 1. So if that's the case, you say the sine of what? Pi over 2 is equal to 1, and this will make it. So suppose that this is equation what? Equation 2. Okay? So this is equation 2. And this is, suppose that it is what? Equation 3. So now we know the value of denominator. Okay, ladies and gentlemen, I think if you finish to copy, in case you find I'm writing quickly, I'm teaching quickly, then you can pause the video, copy the notes, and then we move, right? Because this is the digital program. So if you're digital programs, you have an access to review and to pause, to continue, okay? But you don't have an access of procrastinating the session. So if that's the case, ladies and gentlemen, we go to the first step. So if you go to the first step, we say that substitute equation 3 into equation 2. So what is equation 3? Sine of pi over 2, it is 1. What do you have in equation 2? You have what? Gamma of a half, but this is square. It's equal to pi over sine of pi over 2, which is equal to 1. So ladies and gentlemen, here we have gamma of a half, and then this one in square bracket like this one is equal to pi. So to find the gamma of a half, it means because we consider, remember we consider left hand side, right? So here we say that consider lefty hand side of the given equation. So we have to square to find the square root to both sides. Then on this side we have what? Gamma of a half is equal to what? Square root of what? Of pi. Okay? So then what we have here is what we've been asked to show. So hence what? Hence show So that is from perspective of 40 of the question. But again, you have to note this for the rest of your life in advanced calculus, especially when you're dealing with gamma function. Gamma of a half is equal to under root of pi. So it means that all the positive fractions and negative fractions will be trying our level best to express those fractions in terms with what Z. We have to express those fractions in the smallest unit of gamma of a half, because we know the answer is under root of pi. Right? Good. So let us go to example 7. If you have any question, don't start to ask in the comment section. So example 7. So let us see now how can we find gamma function. And before this example 7, let me give you a note. So therefore, so I say that this is okay. So say that to find the gamma function of positive fraction, right? Positive fraction. Then we use what? We use two properties. First one, gamma of n is equal to gamma of n plus 1 over l. And the second one, gamma of a half is equal to it. Is equal to under root of it. So these properties are enough to solve problems of 40 of gamma function. Are you ready to see the first example? Okay, if the answer is yes, so let us solve one example of gamma function of the positive fraction, which actually has Roman A, B, C, and later on we'll leave the homework for you, so you have to be serious. So this is example 7. Then the question asks you that find, simple. This is how we ask in mathematics. You have short questions. Find Roman 1, gamma of 3 over 2. Roman 2, let us find gamma of what? Gamma of 7 over 2 at the positive fraction. Then we have Roman 3. Roman 3, we have to find gamma of 9 over 2. Because this is an introductory example, we are opening your eyes. It means that we are teaching you something new. We have never, I want to tell you, there are some undergraduate students who are come from advanced education, who are come from 5 and from 6. And they are studying in the same class of undergraduate with students who are come from ordinary diploma. So I know that they used to lie to these ordinary diploma students that we have studied gamma and beta function in advanced education. That is wrong. Myself also, I did advanced mathematics from 5 and from 6, and I taught advanced mathematics for more than 5 years. I have never learned about the gamma and beta function in advanced mathematics myself in that level, and I've never taught any students, and there is no any questions which has asked us about the knowledge of gamma and beta function. We have been dealing with just integration by parts, dealing with maybe integration by trigonometrical substitution, by maybe logarithmic substitution, integrations by the T formula. That's what we have been dealing with. Those are the concepts we've been dealing with. So you should not be isolated. It means that disappointed because you say that if I could pass the route of advanced level, I could know this and start and master this stuff. No, this stuff are not prepared for advanced, for undergraduate students who come from advanced level. This concept or these contents are being laid out for any student from any level to understand and master them. So you should not get disappointed. That's why that I assume all of you have the same level of previous understanding, right? So I will solve Roman 1 to Roman 3 because this is the first. And then in Roman 3, I will start building something in your mind which will excite you, that whenever you see these questions or whenever you find part of when you'll be solving the questions, the long questions, and then maybe at the end you need to apply this concept, you should not spend much time on just doing this one. I teach you the algorithm, the technique. Tell your neighbor that, are you ready to learn the technique? Okay, so let us go. Solution. Solution of what? Example 7. Example 7 what? Roman 1. So we have been asked to find gamma of 3 over 2. Gamma of 3 over 2. So, in order to solve, okay, so we say thank you, sir, for asking us to solve this, find the gamma of 3 over 2. But in order to find that, we have to record that gamma of n is equal to what? Okay, gamma of n, or simply that, I think that I should use this format. So I have to record the second gamma property, the first gamma property, which is the current formula. Gamma of n plus 1 is equal to n gamma of n. That's the formula. Okay? And then, that is, so this is the first step. First step, we call that formula. So if we call that formula, so we go for the second step. The second step, we say that express what? Gamma of 3 over 2. So suppose that this is equation 1. So suppose that this one is equation 1. Okay. So in form of what? In form of left hand side of equation 1. What does it mean? We have gamma, so on left hand side of equation 1, remember to have gamma n plus 1 is equal to what? N gamma of n. So express this one, split 3 over 2. So we have to split it in this form. So to split it, we have to make sure that we have a certain number plus 1. So to get that certain number, just take 3 over 2 minus 1. 3 over 2 is equal to 1.5. 1.5 minus 1. You have what? A half. So it means that in case I want to get 3 over 2, then I can take 1 plus a half. 3 over 2 is equal to 1 plus what? A half. So it means that having gamma of 3 over 2 in that format will be gamma of a half plus what? Plus 1. So remember that this is still equation what? Equation 1. Just write it. Plus 1. So these are the same values. Right? So suppose that this is what? Equation 2. Okay? So it's at equation 2. So on the left hand side we have what? Gamma of a half plus 1. On the right hand side, but gamma, so this is similar to gamma of n plus 1. Our n here is a half. So it means that gamma of n plus 1 is equal to n times gamma of n. So similarly, our value of n, remember that n is equal to a half. So our value of n, so it means gamma of a half plus 1, this is equal to a half. Then we have what? Gamma. Gamma of what? Of n. N is what? A half. Right? So ladies and gentlemen, we say that gamma of a half plus 1, this is equal to a half gamma of what? Of a half, and this will make your equation 3. Okay? So after having that equation 3, we didn't get the answer again. That's not the final answer. That's the intermediate answer. And I believe that you're enjoying the beauty of gamma in vector function. We have to stay. We have to keep enjoying it. So right now, if that's the case, you enjoy, tell me in the comment section, please. Do you understand what am I teaching? Tell in the comment section, please. So for that case, we go for the third step. Third step, ladies and gentlemen, if you examine and diagnose this equation 3, you find on the right hand side, we need to know gamma of a half. And I told you, the questions which you are asking us to show that gamma of a half is equal to square root of 40 of pi, which is this one. So in the third step, you have to recall what is the value of gamma of a half. This is equal to under root 20 pi. And this will make your question 4. Right? Question 4. So you say that substitute If that the case, substitute equation 4. Substitute equation 4 in what? So substitute equation 4 in equation 3. So substitute it, we say that we have what? Gamma of 3 over 2, this is equal to what? A half. Gamma of a half, which is under root pi. So simply, ladies and gentlemen, this is under root pi over 2. So therefore, the answer for Roman 1, gamma of 3 over 2 is equal to under root of pi over 2. Right? That's the response. Then we go for Roman 2. Roman 2, we have been asked to find gamma of 7 over 2. Gamma of 7 over 2. So gamma of 7 over 2 is equal to what, the value of 8. Okay? So we'll be following steps. One of the technique that God has taught me for more than 5 years ago to teach our students by using steps and write in each step what are we doing. So that will make learning to be easy, or to be simple. So the first step, we say that you have to recall what? The gamma property. The first gamma property. Okay, the first gamma property, which is gamma of n plus 1 is equal to n gamma of n. Okay, that is. So if that's the case, we come here. So suppose that this is equation 1. So we go for the second step. Second step now is you have to see the way that you apply. So you say that express gamma of what? 7 over 2. So express it in form of what? In form of gamma of n plus 1. Gamma of n plus what? N plus 1. Okay? So to express in that form, we say that gamma of 7 over 2, this is equal to gamma of what? Of 1. So 7, so we want to split this one into n plus 1. So to split into n plus 1, it means take 7 over 2 minus 1. What do you get? 5 over 2. Remember 7 over 2, it is 3.5. 3.5 minus 1, what do you get? 2.5. 2.5 is equal to what? 5 over 2. So it means that when we find gamma of 7 over 2 is equal to having what? So it's equal to 5 over 2 gamma of 5 over 2, or it's equal to gamma of 5 over 2 plus 1. Right? So simply it means that we say that for this case, because you have to think that 7 over 2 minus 1. The answer is 5 over 2. So that's it. That to say that 7 over 2 is equal to 5 over 2 plus 1. That is. So gamma of 7 over 2, right? Gamma of 7 over 2, gamma of 7 over 2, gamma of 7 over 2, gamma of 7 over 2. So this will make it 1. Okay, so it will be 5 over 2 plus 1. So 5 over 2 plus 1, you get 7 over 2. So you've already expressed this one in this format. Right? So then we say that compare with what? With gamma of n plus 1. So if you compare, in this case, n is equal to 5 over 2. Okay, so this is the value of n. It is 5 over what? 5 over 2. So if that's the case, we say that gamma of 7 over 2 is equal to gamma of 5 over 2 plus 1. Okay, so then we say, if that's the case, you have to remember gamma of n plus 1 is equal to n gamma of what? Of n. Right? That is. So if that's the case, then we know n is equal to what? N is equal to 5 over 2. So to have gamma of 7 over 2, which is equal to gamma of 5 over 2 plus 1, This is equal to what? 5 over 2 gamma of 5 over 2. Do we know gamma of 5 over 2? No, we don't know it. So we let this as writing equation 2. Right? That is question 2. Afterward, we got the third step. Second step. So second step, we say that so the third step, we say that consider gamma 5 over 2 in equation 2. So to consider gamma of 5 over 2, we are using the same principle. Gamma of 5 over 2, so we split this one into gamma of 3 over 2 plus 1. 3 over 2 plus 1 get 5 over 2, so the same value. So for that case, if now we use this property, gamma of n plus 1 is equal to n gamma of n, this will be equal to what the value of n? So for this case, n, our new n, is equal to 3 over 2. So having gamma of 5 over 2, right, and which is equal to gamma of 3 over 2 plus 1, this is equal to what? Is equal to 3 over 2 gamma of 3 over 2. Okay, sometimes you can say, okay, I know gamma of 3 over 2 and then substitute. What if you don't? And I don't, remember I told you that I don't know how, can I teach you to create? No need for you to create, especially this part. We are developing an algorithm. So until the end of this section, you understand that whenever you find gamma for positive fractions, you just find it. You just deal with it within a minute and you are done. Even if that will be given gamma of 21 over 2. That's just the algorithms of writing. You just do multiplication for fractions, then you are done. So this is suppose this equation 3. Again, gamma of 3 over 2 is unknown. So you got the first step. So we got the first step, we say that consider it. So consider gamma of 3 over 2 in equation 3 above. Once you consider it, gamma of 3 over 2. This is equal to it, expressed in form of 40 of n plus 1. So this is a half plus 40 plus 1, right? So what the value of n here, if you compare with left hand side of first gamma property. So the value of n for this case is a half. So if that the case means we have gamma of 3 over 2, this is equal to it. This is equal to gamma of a half plus 1. This is equal to n gamma of 40 of n, which is a half gamma of 40 of a half. So this will make your question 4. Right? That's question 4. So now we know the gamma of a half. Right? So we may just say later on substitute that once. So we say that the fifth step now. We say that substitute equation what? Equation 4 in equation what? Equation 3. Then in what? In equation 2. How? We are looking gamma of 7 over 2. So gamma of 7 over 2, we found here in equation 1, it is 5 over 2. Is then multiplied by what? Gamma of 5 over 2. But we simplify gamma of 5 over 2 is equal to 3 over 2, gamma of 3 over 2. So that one is equal to what? 3 over 2. Then gamma of 3 over 2. But also we expanded the gamma of 3 over 2. And we said this is equal to what? So this is equal to a half gamma of 5. So say here multiplied by a half, then gamma of 40 of a half. You see how simple it is? So then to get gamma of 40, gamma of 7 over 2, then you get it. So simply this is equal to 15 over 4, then gamma of what? Can you fail to finish this question because you don't know the value of gamma of half? I've told you. Okay, so if that's the case, we say that distribute the 60 state. The 60 state, we say that so we say that but gamma of a half is equal to under root of pi. This is equation 5. So gamma of what? 7 over 2 is equal to what? 15 over 2, no, 15 over 4 times what? Under root of pi. So therefore, gamma of 7 over 2, which right now might seem to you that it's difficult, but within a week, we find that it's one of the simplest concepts compared to other concepts. So it's 15 under root of pi of 40 over 4. Response 40, 4, Roman 2. For example, 7 over 40, Roman 2. I believe that you enjoy the beauty of higher engineering and scientific mathematics, and you enjoy the module called the advanced calculus. So, okay, so ladies and gentlemen, so you go for a solution. So you may notice the algorithm that half gamma of 3 over 2 is equal to a half gamma of upper. Gamma of 7 over 2, so you have to lower. You have to lower 7 by 2. While you keep what? The denominator. So gamma of 7 over 2 is equal to 5 over 2 times 3 over 2 times a half gamma of half. That's a trick. So this is example 7, Roman 3. Okay. So we've been asked to find out gamma of 9 over 2. Okay? So that's what you have to find. Gamma of 9 over. So to find the gamma of 9 over 2, can you say, wonderful. Always the first step. Say that we call what? We call what? We call the recurrence form. Gamma of n plus 1 is equal to what? Is equal to n gamma of what? Gamma of that. Right? So listen carefully. Listen carefully. You may do this question now within a fraction of seconds. So let me teach you the trick that I've been saying. So for that case now, we say that we have gamma of what? 9 over 2. This is equal to what? So this is equal to gamma of 7 over 2 plus 1. We have expressed in this 4. So if that's the case, from this side I have 7 over 2, then gamma of what? 7 over 2. Okay? Alright? So here we have what? Gamma of 9 over 2. This is equal to what? 7 over 2 gamma of what? 7 over 2. Okay? So then what is gamma of 7 over 2? Okay? So we keep expanding. So you have 7 over 2 multiply. If you find the gamma of 7 over 2, that's equal to what? Gamma of 7 over 2 is equal to gamma of 5 over 2 plus 1. Right? So when you have gamma of 5 plus 2, no, gamma of 5 over 2, gamma of 5 over 2 plus 1, then you say that, when you simplify that, so listen, so this is 9. Remember that here the value of gamma is 9 over 2. You keep constant, you just minus, you take 9 minus 2, you get 7 over 2. Then you multiply. Then now you take 7 minus 2, you get 5 over 2. Then again, you take now the next numerator, 5 minus 2, is equal to what? Is equal to 3 over 2. Okay? Yes. The technique is this is just check the numerator. 9 minus 2 is 7. 7 minus 2 is 5. 5 minus 2 is 3. Right? It's 3. So if that's the case, then you have 3 over 2, gamma of 3 over 2. Gamma of 3 over 2, which now you have to take 3 minus 1, it's 1 over half. Then afterward, you introduce gamma of 40 of 5. No, square root of 5. Because the gamma of half. So this is the algorithm that you are following. Very simple algorithm. So if that's the case, now you just do the application issues. So 15 times 7 is 105. Then we have 2 plus 2 plus 2 is equal to what? No, 2 times 2 times 2 times 2. So it is 16. Under to 40 of 5. Okay? So that's the response. And a promise that we can give you, because of these solving problems, you'll see often how we use this alternative method of finding gamma of positive fractions, rather than using the longer method. Okay, so it's means that therefore, gamma of 9 over 2, we don't express answers in terms of pi, please, but pi there is still at the same value, 22 over 7. So this is what 100 over 16 and over 5. Okay? So these algorithms is very important. It's applicable in different aspects. For example, this is extra example. I heard that you need more example. You have gamma of what? Okay? For example, you may ask the gamma of 11 over 2. This is gamma positive fraction, right? Okay? Listen carefully. So this one, then we break it down. When we break it down, as I told you that take numerator minus 2, denominator just leave it. So numerator minus 2 is equal to 9 of what? Over 2. Okay, so gamma of 11 over 2, this is, you have decremented numerator by 2, so this will make 9 over 2, then multiply. Then you have what? 11 minus 8, what? 11 minus what? Okay, so gamma of 11 over 2, excuse me, is equal to 9 over 2 times 7 over 2 times 5 over 2, it means 9 minus 2, 7 minus 2, 5 times something, okay? 5 over 2, okay, so then we keep going. We have 3 over 2, it means 5 minus 3. Now 5 minus 2, it is 5, it is 3. Then let us go, keep on going. We have what? We have 3 minus 2, it is 1. The answer of what? Another 5. Okay? Another 5. So I can find that gamma of 11 over 2 and just use that formula. So just multiply 9 times 7 times 5 times 3. Okay, so here we have what? So 9 times 7 times 5 times 3 times 1. While in the denominator we have 2 times 2 times 2 times 2 times 2. And this is under root of 1. So you can multiply numerator and denominator, then you are done. So that's an extra example, bonus example. Say bonus example. I gave bonus to my student. So ladies and gentlemen, so we have been in example 7. So that is example 8. Okay? Excuse me. So say that use So example 8, find a gamma of 13 over 2, 3, gamma of what? Of 15 over 2. So the first one, find gamma of 13 over 2 and gamma of 15 over 2. So ladies and gentlemen, let us continue with our lecture 3. Remember that this is homework 3, not homework 8, which tells us gamma function of positive and negative fractions. So right now, let us go part B of this lecture, which is, let me teach you. I believe you have understood gamma function of the positive fraction. In case you didn't understand any concept, please let me understand. Let me know and ask your questions in the comment sections as well as you can. So gamma function of what? Gamma function of negative. So gamma function of negative what? So gamma function of negative fraction. Gamma function of negative fraction. Gamma function of negative fraction. So to find gamma function, we find gamma function of negative fraction. So properties are used. Okay, then formula gamma of n is equal to gamma of n plus 1 over n, and another one, formula of gamma of a half is equal to under root of pi is r used in evaluation. So to find gamma function of negative fraction, then gamma of n is equal to gamma of n plus 1 over n, and gamma of a half is equal to square root of pi. I'll use the evaluations of those variables. So we need these two expressions, these two equations in order to solve problems. So let us create an example. So ladies and gentlemen, let me present to you example 9. Example 9. Example 9, you have to refer. This is also a question from past paper, refer, ELT. Final exam of 2014. Question 1. Okay, so the question asks you to evaluate Roman 1 gamma of negative a half, Roman 2 gamma of negative 3 over 2, Roman 3 gamma of negative 5 over 2, Roman 4 gamma of negative 7 over 2. So you have these 4 expressions, you have to solve them effectively, and thence we have the general concept. So let us start with a solution of example 9, Roman 1. So we are looking gamma of negative a half is equal to what? Right? So the first step, we have to recall what? Recall the expression that gamma of n, this is equal to what? Is equal to gamma of n plus 1 over n. So if that's the case, we say that afterward you say that express gamma of negative a half in that form. So gamma of negative a half, if you substitute in that formula, this is equal to gamma of negative a half plus 1 over n, which is negative a half. If you compare this expression, then you find n is equal to negative a half. Right? So negative a half plus 1, or 1 minus a half. So gamma of negative a half, this is equal to gamma of positive a half over negative a half. Simply, ladies and gentlemen, gamma of negative a half is equal to what? Is equal to gamma of positive a half divided by negative 1 over 2. So if that the case, the gamma of negative a half is equal to what? Gamma of positive a half multiplied by 2 over 1. So then this will make it 2 gamma of 40 of a half. Okay? So then we say that we have second step. The second step, you have also to recall that gamma of a half is equal to under square. So we say that the gamma of negative a half is equal to what? 2 times under root of what? Of pi. So this is the response. Gamma of negative a half is equal to 2 times 30 square root of pi. Wonderful. So then, ladies and gentlemen, let me solve or find a solution of what? Of example 9. Example 9. Roman what? Roman 2. So the question asks us to find gamma of what? Negative 3 over 2. Okay, so that's the question that we have in the spot. So let us solve together. You can pause the video and then solve the question yourself on the rough paper, and then you come and check the solution. Okay, check my solution. So first step. So the first step, we say that we have to recall the recurrence formula of gamma, which is gamma of n is equal to gamma of n plus 1 over n. Right? So if that the case, then here we have gamma of negative 3 over 2. So for that case, if you compare gamma of n and the gamma of negative 3 over 2, thus n is equal to negative 3 over 2. Right? So you can substitute into that formula. So gamma of n is equal to what? Gamma of n plus 1 over n. So we are looking gamma of negative 3 over 2. This is equal to gamma of negative 3 over 2 plus what? Plus 1 divided by what? Negative 3 over 2. Right? Gamma of negative 3 over 2. Then this to become numerator and negative 3 become denominator. So you can say that you have negative 2 over 3 gamma, negative 3 over 2 plus 1, 1 minus 1.5. So the answer is negative what? A half. So it's negative 3 over 2. This negative 3 over 2 plus 1 is equal to negative half. So then we say that gamma of negative 3 over 2, this is equal to what? Negative 2 over 3, then gamma of what? Of negative a half. Gamma of negative a half. So this will make what? This will make negative 2 over 3. What is gamma of negative a half? So we can express it again. So we can say that if you forget, no need for you to remember, just express this one in this form. So it means we say that this is gamma of negative a half plus 1 of what? Over negative a half. So ladies and gentlemen, gamma of negative 3 over 2 is equal to what? Negative over negative, negative over negative is equal to positive. So it will be 2 times 2 over 3. This becomes numerator, 1 remains as denominator. Then you have what? Gamma of what? Gamma of negative a half plus 1, which is equal to gamma of a half. So this will make what? 4 over 3 gamma of a half. What's gamma of a half? What's the value of gamma of a half? The value of gamma of a half is what? Value of gamma of a half is square root of pi, or under root pi. Okay? So you say that this is gamma of negative 3 over 2, and this is equal to 4 over 3, then gamma of what? Of a half. So the second step, gamma of a half is equal to under root pi. So if that the case, you say that gamma of negative 3 over 2 is equal to 4 over 3 times the square root of pi. And the response. Then we go on solution of example 9, Roman 3. Example 9, Roman 3. Okay? So example 9, Roman 3, the question has been asked to find out. We asked to find the gamma of negative 5 over 2. We've been looking gamma of negative 3 over 2. So this is required. So now you know the principle. So you can pause the video and then solve it. Don't worry to try. Mathematics will try several times until we master the concept. So recall the recurrence formula, which is gamma of n is equal to gamma of n plus 1 of what? Over n. Right? And then afterward we say if this is the case, say fine. So we say that we have to let what? N is equal to negative 5 over 2. So for that case, gamma of negative 5 over 2, this is equal to gamma of negative 5 over 2 plus 1 of what? Negative 5 over 2. So if that's the case, we say that 2 becomes numerator and 5 remains as denominator. So this one will make negative 2, okay, of what? Over 5, negative 2 over 5. Then gamma of what? Negative 5 over 2 plus 1, which is equal to negative 3 over 2. Negative 3 over 2. So negative 2 over 5. So then that is. So you can say that gamma of negative 5 over 2 is equal to negative 2 over 5. Then gamma of what? Negative 3 over 2. This is second equation. Suppose that this is equation 1. Okay, so in this equation, suppose that you don't know. You don't know. If myself, I cannot claim that gamma of negative 3 is equal to what? So if you don't know, then we say that we go to the second state. Second state, we say that consider what? Consider gamma of negative 3 over 2. Gamma of negative 3 over 2, this will make what? So n is equal to negative 3 over 2. This is equal to gamma of negative 3 over 2 plus 1 over negative 3 over 2. So this will make it negative 2 over 3. And then say what? Gamma of what? Negative what? A half. So that is what? Gamma of negative 3 over 2. Okay? So again we go for the third step. Suppose that this is equation what? Equation 3. So consider what? Consider gamma of negative a half. Consider gamma of negative a half. So you have gamma of negative a half is equal to gamma of negative a half plus 1 over negative a half. Right? So for that case, we find that gamma of negative a half is equal to negative 2 gamma of positive a half. So this is equation 4. So we go for the first step. The first step, we say that substitute equation 4 in what? In equation 3, then the result, resultant was the result is substituted in equation 2. So for that case, we say that gamma of negative 5 over 2, so we had here out negative 2 over 5 times gamma of negative 3 over 2 is equal to negative 2 over 5 gamma of negative a half. But gamma of negative a half is equal to what? Times negative 2 gamma of a half. So negative 2 times negative 2 times negative 2 is equal to what? 8. It's equal to 8. It's got negative 8. 5 times 5 is 25. So the answer is negative 8 over 25. Negative 8 over 25. Then have gamma of what? Of half. So this is equal to it. Gamma of negative 3 over 2. Okay? So we say that gamma of a half is equal to square root of 1. So for that case, this is gamma of negative 5. For that case, we say gamma of negative 5 over 2 is equal to it. Is equal to negative 8 over 25. Then times what? Square root of 1. That's the response. Is it correct? Okay. Oh, excuse me. Yeah, it's not correct. Here we had negative 2 over 3. Accidentally, negative 2 over 5. So you know, some students they saw. So excuse me, I made a mistake there. So 3 times 5 is 15. It's 15 instead of 25. And this one also it's 15. Okay. So because I gave you a promise, let us end this lecture. So, example 9, Roman 4, make it your homework. So let me give you an extra question. So example 10, which I'm not going to solve, but I want to show you that these questions have been asked me in different past papers. So refer the T, final exam of academic year 2014-2015, question 1, section A. Question asks you that evaluate. Is this exam or test 1? Excuse me, it's not the final exam. This is question of test 1. So evaluate what? Evaluate on A, gamma of -1/2, which I have taught you. So I want to show you that these questions are being asked. So gamma of -5/2. Okay? So over 2. So this was just a very simple question. We solve this one and we solve this one. Okay? So we solve the part A and part B. So just refer, or you can try and practice and see that these questions are being asked. Ladies and gentlemen, this is the end of lecture 3, which titled as gamma functions of positive and negative fraction. Positive and negative fractions. I thank God who have created me in His own image. I thank you, and I thank God who have given an opportunity to join me and learning the beauty of gamma function and the beta function. This is still, we are building the foundation, we lay out the foundations of gamma function. Later on, we'll teach you about the beta function. So I invite you in the next lecture, which will be lecture 4, when I'll teach you about the duplication formula, and also I'll teach you another about duplication formula, and possibly also after teaching duplication formula, yes, we'll be covering possible duplication formula itself, and possibly if we'll have enough time, I may teach you about the gamma tables. So stay tuned and stay prepared. For gamma tables, I think it will be its own separate lecture. So we'll have duplication table, and lecture 5 will be gamma tables, and possibly lecture 6 will be solving now problems, or we'll be dealing with applications of gamma functions, or solving integrals, infinite integrals. So please remember to subscribe, share the contents, and ask a question in the comment section, just to share these contents with other students. And again, in case you feel from your heart that you want to offer your free will in Thanksgiving, you may offer it to the telephone number 0759 745331, and then your free will in Thanksgiving will be received with the hands of saints. Keep enjoying the beauty of higher and scientific mathematics, and let us meet in the next session. May God bless and protect you until we meet in the next session.